Hello beautiful people and welcome. In this video we are talking about isosceles in equilateral triangles and the theorems and properties that these triangles have. So let's start with the isosceles triangle theorem. So this one says that if two sides of a triangle are congruent. So let's draw a triangle here. Usually it looks something like that. And it says if two sides of a triangle are congruent, then the two angles opposite those sides are also congruent. So if I have these two sides, then this angle here is congruent to the opposite angle here. So let's call this A, B, B, and C. So if segment AC is congruent to segment CB, then the measurement of angle A is equal to the measurement of angle B. Now, how do we know that? Because the opposite angles are congruent, so therefore angle A is congruent to angle B. And how do we know they're equal? Because congruent means equal in measure. Equilateral triangle theorem. It's a very short theorem. It says if equilateral, then equal angular. So what that means is if you have a triangle with all sides that are the same, that means it has to be that all angles are also the same. Now the opposite is true as well. If you have a triangle, I feel like my triangles are getting smaller and smaller by each example, that's okay. If all of the angles are the same, that means all of these sides are the same. So let's go back and do our if and then statements. So if all sides are the same, all angles, then let's put our then statement. Angles are equal. Equal, equal, equal. And equal. Now I'm stuck on that one. That's okay. And then if all angles are equal, then all sides are equal. All right, let's go ahead and see if we can work with these triangle theorems. Example 1, what is the length of each side of the triangle? Again, see what we have, work with what we need. So what do we have? I have two congruent angles. This angle here and this angle here, we know they're congruent because they have the same number of arcs or tick marks. If we have that those angles are congruent, that means we're going to be using the isosceles triangle theorem that says if these two angles are congruent, then these sides are congruent. If these sides are congruent, then we have the angles congruent. Starting with example 1, this one's asking us to find the measure of angle R. So we don't know which one's R, so let's go ahead and label R. Let's do this one R, let's do this one S, and this one T. So let's work with what we have and what we know to determine what we need. So what do we have? We have this tick mark here and this tick mark here. So we have two tick marks. What did those tick marks represent? They represent two congruent sides. And what do we know about two congruent sides? Well, looking back at our beginning of this lesson, if we have two congruent sides, then the opposite angles are congruent. This is called the isosceles triangle theorem. And the isosceles triangle theorem says if we have two congruent sides, that the angles opposite those sides, so in this case angle T and angle S, they're going to be congruent. So what does congruent mean? Congruent means that the angle S and angle T share the same measure. So that means if angle S and angle T are congruent, the measurement of angle S is equal to the measurement of angle T. Well, what is the measurement of S and T? Well, we know the measurement of S is 2x plus 2, so that means the measurement of angle T is also 2x plus 2. Now, how did this help us? Well, because we're trying to find the measure of angle R, I'm going to redraw the triangle here. We know that the measurement of S plus T plus R, so the measurement of angle S plus the measurement of angle T plus the measurement of angle R, we know that's going to be equal to 180 degrees because of the triangle angle sum theorem that we previously learned. So we know that the measurement of angle S is 2x plus 2. We know that the measure of angle T is also 2x plus 2. And we know that the measurement of angle R is 3x plus 1. And all of that's supposed to equal to 180. So that means I have 2x's plus 2x's plus 3x's, so 2, 4, 5, 6, 7 x's. I have 2 plus 2, that's 4, plus 1, that's 5. I'm going to subtract 5 both sides, get my dotted line here to separate out the equation. I have 175 is equal to 7x. Let's see if that gives us a pretty number. Get my calculator here, 175 divided by 7, and that, typed in the wrong number, 175 divided by 7 is equal to 25. So x is equal to 25. Now we have to ask ourselves, is that what it's asking us? So I'm going to shift back up. It's asking us to find the measurement of angle R. So the measurement of angle R, I'm going to separate this out here. The measurement of angle R, that's equal to 3x plus 1. So far, we have only found x. So what we're going to do is do 3 times our x value plus 1, in this case 25. So we have 3 times 25 plus 1, and that gives us the measurement of angle R to be 76. Now you can't just leave 76. 76 what? Puppies, kittens, 76 degrees. Moving on to example number 2. Let's find example number 2. There it is. In example number 2, it's asking us to find the measure of angle P. P for Paul. So they're trying to get us to find that one. Again, what do we have? What does that mean? How do we know? All of the good things. So what do we have? We have 2 tick marks, just like in the previous one, and that means the angles opposite those sides are congruent. So very, very similar question. Here, I would encourage you to pause this video right now, try to do this on your own and see if we can get the same measurement for P. So, because we have 2 congruent sides, that means P and Q are also congruent by the isosceles triangle theorem. So that means angle P is congruent to angle Q by the isosceles triangle theorem. That means the measurement of angle P is equal to the measurement of angle Q. So that means P and Q are both 3x plus 3, 3x plus 3. So again, how does that help us? Well, we know that the internal angle sum of a triangle is 180 degrees. So we have 3x plus 3 and 3x plus 3 and 5x minus 2. All of that's going to be equal to 180 degrees. Combining like terms, I have 3, 6, and 5. So 3 plus 3 plus 5. So that means I have 11x. I have 3 plus 3 minus 2. So 3 plus 3 minus 2, that gives us 4. Positive. I'm going to subtract 4 both sides. 180 minus 4, that is 176, equal to 11x. Dividing by 11, I get x is equal to 16. Now again, what does that mean? Well, right now it just means an x value. It doesn't really mean anything because it's asking us to find the measurement of angle P. So the measurement of angle P is equal to, Well, what is P? P, we said, is congruent to Q, which means their angle measures are equal. So that means P is now also 3x plus 3. So let's plug in our x value, which is 16. Type that into the calculator. So 3 times 16 plus 3. That gives me an angle measure for P of 51 degrees. Moving on to example number 3. Example number 3, I am noticing we have 1, 2, 3. What do we have? We have 3 congruent angles. And what does that mean? If we have 3 congruent angles, I'm looking again at my cheat sheet here, 3 congruent angles, if all angles are equal, that means we're using the converse theorem of the equilateral triangle. So if we have 3 congruent angles, this theorem is called the equilateral triangle converse theorem. And what does that mean? That means if we have congruent angles, that means we have all sides that are the same. Okay, so then we have 5x minus 12 is equal to, because all sides are equal to each other, that means 5x minus 12 is the same measure as 3x minus 4. So we set them equal to each other. Now what's our objective? Our objective is to find DE, which is this side right here, segment DE. We're trying to find this measure. Well, right now all we have are these two sides to work with, so let's work with that. I'm going to solve for x. Usually that's the way to go. I have 2x minus 12. Get my dotted line here to separate out my equation. Plus 12 plus 12. 2x is equal to negative 4 plus 12, and that is 8. Divide by 2, divide by 2. X is then equal to, you guys can't see, x is equal to 4. Again, what does that tell us? Not much, because we're trying to find DE. The measure of DE is congruent to all of the other sides. So if DF, so measurement do I want to do that? No, let's not do that. So that means 5x minus 12 is equal to 3x minus 4, which is also equal to the segment length of DE. So if we find out what one of these are, then we know all of them. So let's choose, I'm going to choose this one here, the 3x minus 4, just because they're smaller numbers. I'm going to plug in 4 in here. So that means 4 times 3 is 12 minus 4, 12 minus 4, and that is 8. So the measurement of DE is equal to the measurement of EF, and EF was equal to 12. Now, it doesn't tell us what it is. It's not degrees because it's not angles. It's not feet, centimeter, inches because there's no units attached. So you can write U for units here. So that means 12 units is equal to EF, which is equal to DE, which is equal to DF. So all sides are the same. Therefore, we can conclude that DE is equal to 12 units. All right, let's see if we have any more examples. We have one more example. Let's find the segment length of AB. And again, what do we have? All angles are the same here. I have to look up how you spell equal because that's bothering me. If all angles are equal, that means all sides are equal. So that means that these three sides are the same. That means that these two are also the same. So that means I have 3/2 x plus 4 equal to 1/5 x plus 9. Now I know what you're thinking. Oh my goodness, it's fractions. Don't let them scare you. They just want to be our friends. Here's your fraction, here's your fraction, here's your x, here's your x. Don't worry about that. Instead, subtract 4 both sides. So I have 3/2 x is equal to 1/5 x. And then I have 9 minus 4, and that equals to 5, positive. And just like we would with a regular whole number, we're now going to subtract 1/5 x minus 1/5 x. Now I'm going to show you how to do this on the calculator so you're not freaked out about fractions. Bring down the 5. Let's do this here. In your calculator, parenthesis, let's see if I can shift this up, parenthesis 3/2. Now, yes, there is an x attached to that. We're going to ignore the x. We're going to just bring it down. So 3/2 minus parenthesis 1/5 equals, and that gives you a decimal. That's okay. Don't worry about that. That we're going to convert to a fraction, and that fraction is 1 3/10. Now 1 3/10 is something difficult to deal with because we're continuing to solve equations. So what I'm going to do is I'm going to convert this to an improper fraction. So 10 times 1 is 10, plus 3, that's 13. That means we have 13x over 10 equal to 5. Now again, yes, you still have a fraction. No, you don't have to worry about it. The last step is you're going to multiply both sides by what's called a reciprocal. So a reciprocal just means you take the fraction and you flip it. So here's your fraction, 13/10, and we're going to flip it to 10 over 13, and I'm going to multiply that both sides. The reason I'm going to do that is because I want to get rid of the 13, and I want to get rid of the 10. So what we're left over on this left side is just x. Here, you can use a calculator if you want. You're going to have 50 over 13 as your x value. Now, if we look at a calculator, let's do here. Let's see if 50 divided by 13 is a pretty number. That is not pretty. That is icky. Icky, icky. And that's okay. We just keep it because this is our x value. Now, what do we need to do with that x value? We need to solve for AB. Now, which one's AB? I didn't actually label, so let's go ahead and label it right now. Let's label it with this one. Let's say this is AB. If AB is equal to 1/5 x plus 9, that means I'm going to plug in here 50 over 13 plus 9. And I'm going to let the calculator do the thinking for me. So I'm going to do 1/5 times 50 13ths plus 9. And that's, once again, is an icky number, but that's okay. We're going to convert that to a fraction, and I get 9 10/13. And that's the size of AB. And that is it. All right, beautiful people, thank you so much for watching this video. If you want to add units here, you can. Just depends on the directions and what it's asking of you. Enjoy the rest of your day, and I will see you in the next one. Bye.